Now on to our next problem. Find the range of this function. We see that we have a polynomial on the top and bottom, and they both have an odd number of terms. We can also see that their coefficients are symmetrical. What I mean by this is that the first and last terms and the second to first and the second to last terms have the same coefficients, same with the bottom. So when we see this, we can divide the top and bottom by x squared and see what happens. This is what we see now. It looks much more symmetrical, and we can start to see a pattern. Let's group x squared and 1 over x squared together, and x and 1 over x together. Now, we know that x squared plus 1 over x squared and x plus 1 over x are related to each other somehow. We know that x squared plus 1 over x squared is equal to taking x and 1 over x, summing them together, and then squaring them, and then subtracting away the extra term, that's 2. So if we can represent x squared plus 1 over x squared using x plus 1 over x, we can let a, another variable, be representing x plus 1 over x. And when we do this, when we introduce a new variable, we have to immediately think about the ranges and the bounds for the values of this new variable. When x is greater than 0, a is greater or equal to 2. But when x is less than 0, so when x is negative, a is less than or equal to negative 2. So now let's rewrite our expression for f of x using a. We would get a squared plus a minus 4 over a squared. Now let's divide a squared into each term. Now we have a quadratic. We can let 1 over a be equal to b because we see a repeat. So we have negative 4b squared plus b plus 1. Now let's factor this quadratic and turn it into not the standard form, but the vertex form. We can factor out a negative 4. And this is what we're left with. Our original question asks us to find the range of f of x. So what are the possible values for b? We know that b is equal to 1 over a, and a had restrictions here. So then b can be between 0 and 1/2, or between negative 1/2 and 0. F of x reaches its maximum when b is equal to 1/8. And this is possible because 1/8 is within our range of possible values for b. And f of x reaches its minimum when b is as far away from 1/8 as possible, which means b has to take on the value of negative 1/2. So let's substitute these values of b into f of x and see what we get. Our maximum value would just be equal to 17 over 16. And our minimum value would be negative 4 times negative 5/8 squared plus 17 over 16. This is equal to 25 over 64 times negative 4 plus 17 over 16. This is equal to 17 minus 25 over 16. This is equal to negative 8 over 16, which is equal to negative 1/2. So now we have found the minimum and maximum possible values for f of x. The range for this function is negative 1/2 to 17 over 16 inclusive.